that the chemistry is missing here because the chemistry gives us so many, and there's good science gives us so many of the more complicated ranges of what the brain can do. So I thought that was a great point. I was really struck by one of our debaters that said, and this was the opener, I thought it was great, that in fact the brain uses memory to recall states, but it's also connected to the body and a sense of movement of the body. Now that's a tricky definition because then we get into that epiphenomenal discussion of does a machine have a body? We went there last week. But the body itself is usually not enough. When we talk about consciousness, human consciousness, there's the argument you need an awareness of the body and a theory of the mind. Those are generally the two critical requirements for human consciousness. So if you were going to speculate, Jeff, and you thought about machine consciousness in that way, what would the theory of the mind be?
Well, a theory of mind, remember, the cortex just builds a model of the world, right? That's what it's doing. It has a very methodical method for doing that. And so we can build a model of what a stapler does. We can build a model of what a computer does. And we observe humans, and we can build a model of how humans behave. We also observe ourselves, and we have a model of how we behave. So I think about a theory of the mind is really not much different than a theory of anything that we observe. We have to come up with a way of representing how something behaves when we interact with it, whether it's a smartphone or whether it's another human. And now, obviously, it's not so black and white like that because we have, built in the behavioral emotions and responses that are outside of the neocortex, and so it's not so dry like that. But I think in general, a theory of the mind is like a theory of anything, and it's not really. It goes back to this common sort of modeling system. It's like we can figure out, imagine I saw an alien being that had a different type of mind. I interacted with it a bit. I'd have a theory of its mind too. It may be a good theory, maybe a bad theory, but I would develop a theory of that. And so I don't think it's a separate thing, theories of mind. I think it's outside of what we might have built into our genetics, into our older brain sections. If we take that out of the picture, a theory of the mind is like a theory of a smartphone. It's just, we build models of things. And then we use those models to make predictions about what would happen under certain conditions. Maybe you don't like that answer, but that's, I'll make a comment about the chemistry. It's interesting to hear that. I just want to point out in the work we do, the theories we work on, I didn't talk about all this in the book, but we deal with things that are very sort of physics. For example, the way grid cells work in the brain, it's believed have to do these oscillatory interference models. And so you have to have a lot of the sort of like physics concepts to understand them. We do a lot with chemistry as well. When we talk about dopamine release or neuromodulators, it's all chemical reactions, and those are graded reactions. They're not like, they're not binary or digital. And of course, neurons, sometimes they act as probabilistic machines on the firing rate, sometimes they don't. So I think, it's interesting. I think just to comment, neuroscience is actually to be good at it, you have to deal with many different types of scientific disciplines and be willing to think about them in some sense simultaneously. I'm not claiming I'm good at all those, but I'm just saying that it's not like a computer and you can just say, well, it's all digital bits, it's not like that. Sometimes it's a little bit like that. Sometimes it's like, it's like probability, and sometimes it's like chemistry. And it's being able to tease apart the different components at different times. It makes it very challenging work.
I was a big fan of this treatment of consciousness because I do think it's related to memory, and not just to the capacity for memory, but it's that more fundamental idea of memory to construct a model of the self and the self as a reference frame. And I just find that incredibly illuminating. And the point that Avery's referencing is, I had started to think about, do we create a model of the self? Do we create a reference frame of the self in order for us to have an internal representation of what others see, which is us as continuous beings to which we can attach reputations and interactions. So I need an internal model of how others see me in order to, for example, make sure that I treat them in ways that will encourage them to continue cooperating with me. So this is a concept of the self and consciousness that I've been playing around with. And I just found this a really the concept of the self as a reference frame. And I think that's what memory does. It's not memory on its own. It's the capacity to construct that model. You need memory to be able to do that, the connection of experiences.
I think that's an interesting point, Jillian. You know, that we need this model of ourselves to know how other people perceive us. I certainly agree with that, although I wouldn't say that's the only reason we need a model of ourselves. We need a model of ourselves just to know how to behave and act. And if I was lost in the woods by myself, I'd still need a model of myself to know how to, like, you know, do things and what might hurt me and things like that. But I think it does have that secondary benefit, I suppose, that helps other people, helps me know how other people will perceive me. I think so many of these things can be resolved if we just realize the brain makes a model of everything. Any experience it has, it tries to build a model of it somehow, and right or wrong, and it can get sort of at the core of many of our social interactions. So that's an interesting point.